the magnitude of these the resultant magnitude of these two forces is 500 Newton, and it is directed along the positive y-axis, right? So the magnitude and direction of the resultant is given, and we are asked to determine the magnitude of this force and this theta which this force is making with the positive x-axis. So let's suppose if I draw the free body diagram, right? So let's suppose if this is the positive x-axis and this is the positive y-axis. So let's suppose if this is that force F which is making some angle, which is we are asked to determine this angle. So let's suppose if this is that force, we need to determine the magnitude of this force and this theta, right? And we are also given that the resultant is 500 Newton and it is acting towards the positive y-axis. First let me draw that resultant, right? So this is also given. So let's suppose if this is that resultant, so this is that resultant vector. So by head to tail rule we should get this resultant, right? So we need to complete this triangle, right? So if I draw the force which will join the head of this F with this R, right? So let's suppose if this is F1, right? So then this is that F1, right? This is 700 Newton and this is that F. I will write this F, right? And the magnitude of this resultant is given, right? So this is 500 Newton. And this force F is making 15 degrees with the horizontal, right? So let me represent that angle as well, right? So let's suppose if this is that horizontal line, right? So this angle is given, right? So this angle is 15 degrees and the magnitude of this is F1, right? And F1 is 700 Newton. So if this is 15 degrees, so then this angle is also 15 degrees, right? And this angle is 90 degrees, right? This angle is 90 degrees and this 15 degrees. So now from this we know this angle, right? So this angle, so this green angle is, let's suppose if this angle is alpha, so then alpha angle is equal to 90 plus 15 degrees, right? So this alpha is 105 degrees. So now this resultant magnitude is known, this F1 is known, which is equal to 700 Newton, right? So we know these two lengths and we know the included angles, so we can find the magnitude of this F using the cosine's law, right? So F squared will be equal to F1 square plus R square minus 2 F1 into R cos of the included angle. The included angle is alpha, right? So we will write, if I put the magnitudes, so then this is 700 square plus 500 square minus 2, and F1 is again 700, R is 500 cos of 105 degrees, and we will take the under the root 2 in order to get the force magnitude, right, which is required. So if I solve this using calculator, so we will get the magnitude of this force. So let me solve this. So this force is approximately 960 Newton, right? So this is the magnitude of that force. And now we are asked to find this theta, right? So now if we find this angle, let's suppose if this angle is beta, right? So if we find this beta angle, so then this theta will be, and as we can see that this theta plus beta is equal to 90 degrees, right? So then we are asked to find theta. So theta will be equal to 90 minus beta. So now we will apply sine's law in order to find this beta, right? So if I apply sine's law, so I will write sine of beta divided by the magnitude of the opposite side. So this is the opposite side, that F1, so I will write F1, and this will be equal to sine of alpha divided by the magnitude of the opposite side, so that is F, right? So now we know the magnitude of this F. So beta will be equal to sine inverse F1 into sine of alpha divided by F magnitude, right? So if I put the values, so we will get beta angle, right? So F1 is how much? So it is 700 sine of 105 divided by 960 newtons, right? So when I solve this, so beta comes out to be 44.77 degrees, and now we are asked to find this theta. So then we have written this equation. So theta is equal to 90 minus beta. So 90 minus beta, so beta is 44.77, right? So theta comes out to be 45.2 degrees, right? So this is the angle of the force F with the positive x-axis. So this is the solution of this problem.